Hey guys, welcome to this Mometrics video over anion, cation, and the octet rule. Anions, cations, and the octet rule all have to do with atoms and their stability. Atoms will do anything within their power to be stable. Stability for an atom means that they have 8 electrons in their outermost shell. The electrons in the outermost shell are called valence electrons. Valence electrons are the things that the atoms want 8 of. And this is exactly what the octet rule refers to, the tendency of an atom to try and become stable by having 8 electrons in their outer shell. Atoms will go to great lengths to become stable. They will give electrons away, and they won't even think twice before they decide to steal electrons from another atom so that they will become stable. This is where ionic bonding comes in. Starting out, atoms are electrically indifferent or neutral. They have an equal amount of negative and positive particles. Negatively charged particles are called electrons, and positively charged particles are called protons. Well, when atoms lose their neutrality, they sort of go under an identity crisis. They are then called ions. An ion is an atom that has had an electron taken from it, or an atom that has taken an electron from another atom. So an ion is not neutral. It is either negatively charged because it has an extra electron, or it is positively charged because it is missing an electron and therefore has more protons than electrons. An atom that has had an electron stolen and in effect has more protons than electrons is called a cation. So a cation is a positively charged ion. An atom that has stolen an electron and therefore has a negative charge is called an anion. Let's look at some examples. Sodium, Na, is a very vulnerable element. It only has one valence electron. So for sodium, if it got rid of that electron, then it would be full in its now outer shell. But it would also be positively charged with 10 electrons and 11 protons. So in getting rid of an electron, sodium becomes unbalanced and positively charged, and is therefore a cation. Cations are noted with a plus sign superscript. This represents that it is positively charged. Chlorine, on the other hand, is 1 electron away from having 8 in its outer shell. So it wants very desperately to steal an electron. In stealing an electron, it becomes unbalanced and negatively charged. Therefore, it is an anion. Anions are noted with a negative sign superscript. This notation represents that it is negatively charged. Atoms can require or discard more than 1 electron at a time. Let's say we have the magnesium +2 cation and the phosphate -3 anion. Magnesium has an atomic number of 12. And remember, atomic number refers to the number of protons in the nucleus of an atom. So if it has an atomic number of 12 and magnesium +2 has a +2 charge, then that means it has 2 more protons than electrons. This means that it has lost 2 electrons. The protons aren't going anywhere. An atom will always keep the same number of protons that it starts with in its balanced state. The electrons are the ones changing. So if you see that an element is noted with a plus or minus, you can look at that number that follows, so in our case magnesium is followed by +2, and we can subtract 2 from our atomic number 12, and that will give us the number of electrons of that ion, which is 10 electrons. The phosphite ion has an atomic number of 15, so that is 15 protons, and it has a -3 charge. So it has gained 3 electrons. So we can add 3 to our number of protons, and that gives us our number of electrons in the ion. This means our phosphate anion has 18 electrons. I hope that this video over anions, cations, and the octet rule has been helpful to you. If you enjoyed it, then be sure to give us a thumbs up and subscribe to our channel for further videos. See you guys next time.